It is a Tuesday morning at Pickering, on the North Yorkshire Moors Railway, and a train built in 1935 is being prepared for service, not displayed, not preserved under glass, not recently restored for a special occasion, and then carefully regaraged, prepared for service. The coach, an LNER teak third corridor, constructed at Doncaster Works in the decade between the Silver Jubilee and the war, is being cleaned, checked, and coupled. Its buffers will engage. Its brakes will be tested. Passengers will sit in it this afternoon. The varnished teak exterior, that instantly recognizable warm grain, is not an affectation. It is not there to signal heritage. It is there because teak was the engineering choice, a timber that hardens with exposure and resists moisture penetration with increasing efficiency over time. The older it gets, the better it performs its primary function. This is not a coincidence. It is a design philosophy. The LNER, the London and North Eastern Railway, it built its standard coaching stock from teak-panelled bodies mounted on steel underframes, bolted together in a modular arrangement that allowed individual components to be removed, repaired, and then replaced without structural compromise to the whole vehicle. Sir Nigel Gresley formalised this approach from 1923 onwards at Doncaster Works. The same basic specification, 60-foot underframe, bolted teak body, Gresley double-bolster bogies, continued with minimal modification until 1942. A design that ran unchanged for nearly 2 decades was not an oversight. It was confidence. These coaches have been running in some form for over a century. The question is not why they survived. The question is what we were thinking when we started building things differently. Before we get to the bolts, and we will get to the bolts, because the bolts are the entire argument. If you are the kind of person who has stood next to a piece of vintage engineering and thought that should not still exist, this channel is built for you. Still Working UK documents the British machines and infrastructure that were designed to be repaired, not replaced. We are not interested in nostalgia. We are interested in why things last and why we stopped building them to. Subscribe. There are more of these. You will not be disappointed. The coaches that Gresley, designed for the LNER from 1923, were not intended to be remarkable. They were intended to be standard. That distinction matters more than it might initially appear. Standardization, genuine standardization, not the bureaucratic kind, means that any works with the right jigs can build the same component. It means parts from a coach condemned at Newcastle can be used to repair one at Norwich. It means the knowledge required to maintain the fleet is not singular and untransferable. It is distributed, codified, and teachable. This was not a new idea in 1923. Joseph Whitworth had codified thread, so standardization in 1841. The Great Western had standardized its locomotive designs under Churchwood decades before, but Gresley applied it to coaching stock at a scale, and with a persistence that produced something genuinely durable. The teak coaches that served the East Coast Main Line in the 1930s were not merely old when they ended their mainline careers in the mid-1960s. They were rebuildable, and some of them were rebuilt. And some of those rebuilt coaches are running today. The choice of teak was not romantic. It was engineering. Burmese teak, Tectona grandis, had been the material of choice for marine construction for centuries before it found its way into carriage building. The Royal Navy had used it extensively in ship decking because of its specific combination of properties. A high natural oil content, which resists moisture and prevents swelling. A silica content that dulls cutting tools but simultaneously resists insect damage. And a grain structure that becomes progressively more stable as the wood ages and dries. In a railway carriage, these properties are not incidental. When a coach body is a structure under constant dynamic loading, it vibrates, it flexes, it is exposed to temperature extremes, rain, condensation, platform exhaust, and occasional impact. A material that strengthens with age rather than degrading with it is not merely convenient, it is a significant engineering advantage. The LNER's teak coaches were built with their bodies assembled as a bolted cage of teak pillars, rails, and panels on a steel underframe. Individual panels could be unbolted and replaced without disturbing the structural integrity of the coach. Interior fittings, seats, racks, partitions were similarly accessible. A damaged compartment door was a component, not a section of welded structure requiring specialist cutting equipment and careful repassivation of the joint. The workshops that maintained these coaches, at Doncaster, at Stratford, at York, held pattern drawings for every component. A clerk with a catalogue could identify the part. A skilled tradesman could fabricate a replacement on site. The system as a whole was maintained by a network of knowledge, local knowledge, workshop knowledge, tradesman knowledge that was never required to be concentrated in a single facility. If Doncaster was unavailable, York could do the work. If York was committed, Stratford could step in. This is not how we build things now. The reasons given for this are usually economic. The actual reasons are more complicated, and the coaches standing in Pickering Yard this morning are a reasonably compelling counter-argument to all of them. Doncaster Carriage Works was, by the 1920s, one of the most capable carriage building facilities in Britain. The works had grown with the Great Northern Railway, and when the LNER absorbed the GNR in the grouping of 1923, it inherited not just a railway, but a manufacturing tradition. The basic construction sequence for a Gresley teak coach began with the steel underframe, a fabricated box section structure of considerable rigidity designed to absorb buffing loads in the longitudinal direction without permanent deformation. This underframe was the structural spine of the vehicle. Everything else was attached to chit. The body framework was assembled from teak pillars and waist rails, bolted to steel brackets that were themselves bolted to the underframe sole bar. These brackets were not welded in place, they were bolted. This distinction is central to the argument. A bolted connection is, by definition, reversible. It can be disassembled, it can be inspected, it can be replaced without disturbing the structure around it. The exterior panelling, teak boards of varying thickness, shaped to the profile of the coach side, was fixed to the framework by further bolting and screwing, with the grain running horizontally to maximize the visual effect of the varnished finish, and incidentally to align the natural flexibility of the timber with the axis of the panel's primary loading. Interior partitions and trim were similarly bolted or screwed. The bogies, Gresley double bolster design, mounted on a 61-foot 6-inch underframe, were themselves bolted to the underframe sole bars and kingpins, and could be dropped and exchanged during a standard periodic overhaul. The result was a vehicle in which there was virtually no component that could not, with the correct drawings and the correct timber, be fabricated, refitted, and returned to service. This principle would be inherited directly by the BR Mark I of 1951, which applied the same modular logic to all steel construction, and produced a coach so repairable that heritage railways are still running examples 70 years later. The philosophy did not change, the material did. The longevity, as it turned out, travelled with both. Behind every coach that runs today on the North Yorkshire Moors Railway, the Severn Valley Railway, or the North Norfolk Railway, there is a maintenance culture that has outlasted the organisations that created it. The LNER's carriage and wagon department maintained a standard of documentation that was, by the standards of the era, exceptional. Workshop bulletins were issued regularly, specifying materials, tolerances, and assembly sequences for every component type. These bulletins were retained in works libraries. Many of them have survived. Volunteers on heritage. The railways routinely refer to original documentation when undertaking restoration work, not because they are being precious about authenticity, but because the drawings specify the correct dimensions, the correct timber grades, and the correct bolt torques. This is the invisible infrastructure of maintenance culture, the knowledge codified at the point of original manufacture, preserved through institutional habit, and now residing in the filing cabinets of heritage railway carriage departments across Britain. The LNER Coach Association, based at Pickering on the North Yorkshire Moors Railway, maintains a fleet of 22 heritage and vehicles, the oldest dating from 1894. The restoration team works to original drawings where they exist, fabricates replacement components to pattern where they do not, and sources teak from specialist timber merchants who supply material to the correct specification. Sourcing teak to Edwardian specification in 2026 is not simple. The Burmese sources that supplied the LNER's carriage works are no longer commercially available in the same grade. But seasoned teak of appropriate quality exists, and the Heritage Railway Workshop Network has established the supply routes. The knowledge of how to cut, shape, and fit teak coach panels, so knowledge that British Railways effectively abandoned in the early 1950s as it standardized on all-steel construction, has been reconstructed, largely by people who learned from people who were there when the last teak coaches were built. This is how engineering knowledge survives. Not in archives, in practice, in people, in the quiet insistence that the old method works, because the coach in the siding proves it. In the early 1960s, British Railways decided that its pre-nationalisation coaching stock had reached the end of its useful life. This decision was not entirely unreasonable. The teak coaches were wooden-bodied in an era of increasing focus on crash resistance. The BR Mark I had demonstrated, at the Harrow and Wealdstone crash of 1952, that all-steel construction provided meaningfully superior protection in the event of a collision, a fact that the Chief Inspecting Officer of Railways specifically attributed to the Mark I's introduction as a primary reason for the decline in railway fatalities from 1955 onwards. British Rail's operating departments, however, were not sentimental. The scrapping program that followed was rapid. By the mid-1960s, most of the LNER teak coaching fleet had gone. The scrapmen, as one contemporary observer noted, simply burned the teak bodies. They were interested in the metal content. The frames were cut up, the bogies were processed, the interior fittings were dispersed. Coaches that had run for 30 and 40 years on the East Coast Main Line, carrying passengers between London and Edinburgh and Aberdeen and Hull, were reduced to their constituent materials in months. The preservation movement that emerged, and in the 1950s, was not yet large enough to intercept most of this. The Tallillin Railway had shown from 1950 that volunteer operation of heritage lines was viable, the first such railway in the world. But what was saved by individuals acting quickly, often without institutional support. The North Norfolk Railway's LNER Quad Art set, articulated coaches built in 1924 to a Gressley design, survived as the only complete example of the type in existence. Every other steam-age articulated carriage set built by the Big Four was scrapped. Every single one. The coaches that did survive often did so in departmental service, are gutted, repurposed as staff vans and breakdown coaches, and were acquired later by preservation societies in poor condition. They were rebuilt because they were bolted and because the drawings still existed. The Severn Valley Railway operates 7 LNER teak coaches in regular passenger service, including Buffett car number, a 643, a kitchen composite of 1936 vintage that required, during its preservation restoration, the replacement of nearly every bolt and steel tie in the body, along with most of its exterior teak panels. This sounds like a rebirth rather than a repair. And in a sense it was. But what it demonstrates is the fundamental difference between a bolted modular structure and a welded one. When you reach the point of wholesale component renewal, the bolted vehicle can, in principle, be rebuilt to its original specification. The structure is not monolithic. It is an assembly. Assemblies can be disassembled. Disassembled things can be rebuilt. The North Norfolk Railway's quad art set, built 1924, restored between 2003 and 2008 at West Coast Railway Company at Carnforth, underwent a 5-year program that removed most of the changes British Railways had made in the 1950s and returned the coaches to their original 1924 condition. The varnished teak returned after 60 years. Additional sections of rotten frame were found as the coaches dried out. They were patched or replaced. It was bolted back together. Railway historians have described this set as the most historically important coaches in preservation, not housed in the National Collection. They run on the North Norfolk Railway. They have been doing so, in one form or another, since 1967. Meanwhile, the BR Mark Is, all steel, bolted underframe, replaceable body panels, form the backbone of heritage railway operations across Britain. The North Yorkshire Moors Railway, the Keighley and Worth Valley Railway, the Bluebell Railway in Sussex, all rely substantially on Mark I stock built between 1951 and 1963. These coaches are over 70 years old. They are, and not in museums, they are in service. The 1980s rolling stock that replaced them on the main line is already, in many cases, withdrawn and scrapped. The design life has been reached. The leasing arrangements have concluded. They are gone. The Mark Is are still running. There is a coach at Gromont on the North Yorkshire Moors Railway that has been in service, in one form or another, for the better part of a century. Its bogies have been exchanged. Its interior has been retrimmed. Some of its teak panels have been replaced, fabricated from timber sourced to the original specification. It is in daily service. The maintenance required this quarter is the same maintenance it has required every quarter for the past several decades. Bogie lubrication, brake block inspection, and attention to a gangway seal that has been weeping since the spring and will be replaced during the next scheduled works period. The parts are available. The drawings exist. The workshop has the tools, the skills, and the institutional memory to do the work correctly. The machine is still running. It will be running tomorrow. It will require maintenance next quarter. The same maintenance it has required every quarter since the Suez Crisis. The parts are available. The knowledge exists. The will to continue is present. None of this is remarkable. It is simply what happens when something is built correctly. The remarkable thing is how rarely we do it. If this was useful, and you are the kind of person for whom knowing how a thing is built changes how you think about whether it lasts, this channel has more where this came from. 40-year-old pump engines still running at Victorian waterworks. Mill machinery under load 70 years after its builders closed. Lock mechanisms on the canal network, maintained to the same schedule as they were in 1815. None of it is remarkable. That is precisely the point. The